So today I'm covering 2.7, section 2.7. We have the first objective we have to omit. The second one is identify even and odd functions. And then we are going to do graph piecewise defined functions. And then investigate increasing, decreasing, and constant behavior of functions. So I'm going to start from problem number 5. So this is the definition for identifying if it's even or odd function. So the rule is, first you have to replace all the x by negative x. So number 5, this is the given problem. So we are going to replace all the x here by negative x and see what we are getting, the result. So I replace all the x by negative x. So we get f of negative x equals negative x to the power 4 is when you multiply negative number even number of times, it becomes positive, minus, and then again even power, so it's going to be x squared plus 2. Now compare this one with the original function. So this is what we got after we replace x by negative x. And look at the original function, which is also the same. They both are the same. So if you get the same function after you replace x by negative x, then the function is going to be even. So we are moving on to number 6. So we are given f of x equals x to the third minus x plus 3. Now again, let's replace all the x by negative x. So here we have the odd power. So when you have the odd with negative, it's going to be negative. So minus of minus x is going to be plus x plus 3. Again, we are going to compare this one with the original function. If you look at that one, the first sign has been switched, the second sign has been switched. So it's not exactly the same and it's not the opposite. If everything is opposite, then it's odd. So this is not same or opposite, so it's neither even nor odd. So I'll show you the next one when the function is going to be odd. So this is the given function. So we are going to replace the x by negative x. So we get f of negative x equals, since it's odd power, so it's going to remain as negative. Again, this is odd power, so it's going to be negative, but negative times negative is going to be positive. So let's compare this one with the original function. The original function is x to the third minus x. And if you look at that, the first one is the opposite. The second one is also opposite. So we got both signs switched. So it is basically, this is negative of x to the third minus x. So it's the opposite of the original function. So that means f of negative x is equal to negative f of x. So this function is an odd function. Okay, so we have seen one example for each, which is first one was odd, the second one was neither, the first one was even, second one was neither, third one was odd. So we are moving on to the next objective, which is graph piecewise function. So we are going to see more than one graph because we are going to have more than one function for the same for more than one equations. So let's take problem number 8. We are given two functions, x squared plus 1, where when x is less than 0, that means for all the numbers less than 0, this is the function we are going to use. And next one is x minus 1 for all the numbers greater than or equal to 0. So first we are going to learn how to evaluate the function for the given values of x, and then we are going to learn how to graph. So let's take f of negative 1. Okay, so is this negative 1 less than 0 or greater than 0? Negative 1 is less than 0, right? So that means it belongs to the first one. So we have to take the first one, which is x squared plus 1. In this one, we are going to replace the x squared by what? This negative 1. This negative 1 goes here. And so negative 1 square is 1 plus 1. So the answer is 2. So we got f of negative 1 is 2. Next one, we have to find f of 5. So 5 is 5 greater than 0? Yes. So it belongs to the second function. So when the number is greater than 0, we have to take the second function, which is x minus 1. Now we are going to replace this x by this 5. 5 minus 1 is 4. So f of 5 is 4. Next, we are going to find f of 0. Again, 0 is equal to 0. That belongs to the second function, which is x minus 1. So we're going to replace this 0, x by 0. So the answer is negative 1. So this is how we evaluate the function for the given values of x. So we have one more example for this. So we are given 3 pieces here. So h of x. The first one is x squared plus 3 for all the numbers less than 2, for all the x less than 2. And it's going to be just 7 when the numbers are between 2 and 4, and can be equal to, it's equal to 2 and equal to 4, and between 2 and 4. And the last function is 2x minus 1 for all the numbers greater than 4. So now we are going to go one by one. So first one is h of 1 and see where it belongs. So we have 3 conditions. We'll have to go by these conditions here, or the constraints. Is 1 less than 2? Yes. That means we are going to use the first one. So, and you're going to replace all the x by 1 because we have 1 inside here. So we're going to put the 1. And 1 squared is 1 plus 3. So the answer is 4. Next one, we have h of 3. So now look at that. So 3 belongs to which constraint here? It's not less than 2, so we cannot go. It's not greater than 4. That means it's between 2 and 3. So the answer is just 7. So we are done. There's no x here, so we cannot calculate anything here. So the next one is h of 4. And 4 belongs to which function here? Again, it doesn't belong here. The first one, the 4 is here, the second one, because 2x is less than or equal to 4. So that means the answer is going to be just 7. And the last problem in this one, last part is h of 5. 5 is greater than 4. So that means it belongs to the last one, which is 2x minus 1. So we're going to use the last function, So 2 times 5 is 10 minus 1. So the answer is just 9. So the next problem, number 10, we are going to actually graph the function. So let's learn how to graph this piecewise function. So let's take problem number 10. And for all the x less than 2, and the next condition is for all the x greater than or equal to 2. Okay. So now what we are going to graph. So we know for graphing any function we need points, correct? So we have to pick points for each condition here. So I'm going to make a table for the first one. We are going to make 2 tables for all the numbers less than 2 and for all the numbers greater than or equal to 2. So let's make the table. So we have to plug in x value, and here what is y? Y is for the x less than 2. Y is given as 1/2 x plus 1. So we're going to plug in whatever the number we choose. We are using the first condition. So let's say less than 2. First I'm going to take the 2 as well, and then less than 2 is 1 and 0. Or let's take, instead of taking 1, let's take -2 because we have the fraction. So when I put 2 here, I'll show you why I'm getting 2. It's not equal to 2, but still we have to take the 2. So when I put the 2, we get 2 here. When I put -2, it's going to be 0. When you put 0, it's going to be 1. Okay. Next, so let's make the table first. So for the x or x less greater than or equal to 2, we are going to use the second function. So we're going to start from 2 and greater than. So that means we can go 2, 3, and 4. When I put 2, it's going to be -3. 3 is -4, and 4 is -5. So now let's graph this 2 functions here. Okay, now, so let's take the first one. So I'm going to use different colors. The first graph, I'm going to use red one for this one. So 2, 2. So I go 2, 2, but 2 is not included, so I have to keep it open. And then -2, 0 is this point, and 0, 1 is this point. So the graph stops right here. However, it grows, it's going beyond this one. And we're going to use blue for this function, for the second one, blue. And then 2, -3 is down here, and it's closed because the point 2 is included. Because see, do you see the equal sign? That means it includes the point 2. And then 3, -4. 3, -4 is here, and then 4, -5 is right here. So the graph goes underneath here, and this point is closed, that point is open. So these are the 2 functions. Because we have only 2 functions here, we had 2 pieces. So that's why it's called the piecewise function. Let's go to the next example, number 11. So we have z of x. So we are seeing 3 pieces here. So -1 for all x less than 0. And the second function is x minus 1, where x is between 0 and 2. and both are included, and negative 2x plus 6 for all x greater than 2. So now, since there are three functions, we are going to make three tables. So for all the x less than 0, the y is going to be negative 1. So no matter what values you are choosing, first always include this number, and then less than, so it's going to be negative 1, negative 2. Whatever the values you choose, y is going to be just negative 1. The next one is between 0 and 2. So the function is x minus 1. So you have to choose, you can choose 0, and the next number is 1, and you can include 2 as well. So when I put 0 here, 0 minus 1 is negative 1. When I put 1, 1 minus 1 is 0, and 2 minus 1 is 1. And the last table is for all the x greater than 2. That means you can choose numbers greater than 2, and the function is given as negative 2x plus 6. But I'm going to include the 2 as well, then 3, 4. So when I put 2, it's going to be 2, and I put 3 here, it's going to be 0. When I put 4 here, it's going to be negative 2. So now you know why I include these numbers, because we have to keep that point open circle here. That's why we have to put the end points. So now let's graph this one. So I'm going to use red for the first one, green for the second one, and blue for the third one. And my graphs, this is the space I have to use. Okay, so let's do 0, negative 1, and 0 is not included. So this is the point 0, negative 1, so I have to keep it open. And negative 1 is this, and negative 2, negative 1 is this point. So it starts from 0, it goes like this. Okay. Next, I'm going to use the green for the next one, and then again 0, negative 1, and it's included. So I'm going to close this point again. So I have to do on the top, and then 1, 0, and then 2, 1. So the graph, the line goes like this. The last one is 2, 2, but 2 is not included. So I'm going to keep it open. 2, 2. And 3, 0, and 4, negative 2. So the graph is going like this. Okay, sorry, I made one mistake here, because it's a closed one, 0 to 2. So it's 2 is 1. So this line is just closed. We cannot go any further down. I'm sorry. And this because it starts from 0 and it ends at 2, so I cannot go about. So that is problem number 11. And then we are going to find the increasing and decreasing intervals. So I'm going to just do one example here. So the graph, So it goes this. So we are, it's very hard to explain on this one, but I'll try my best. So you have to find the increasing, decreasing, and constant. Increasing mean when it goes from left to right, it's increasing. When it is flat, it's constant, and this is decreasing, and again this is increasing. So if you look at the graph, we have increasing from negative infinity up to, it goes up to -2. So I'm going to write negative infinity to -2. And again, it increased from this. We have to look at only the x values. So it's increasing from 2 and it goes all the way up to infinity. So there are whenever you have two intervals, we have to use the union symbol. Next one is decreasing. So decreasing means when it falls from left to right, it falls. So this is falling from here to there. So this is 0, starting from 0, and it goes up to 2. It falls at 2. So we are looking only at the x values. So constant. So it's from -2 to 0. It's constant. So I think you can try the rest of them. This is not that hard. So I'm going to stop right here. Okay. Thank you for watching.